All right, so this is the last of the applications of these things, logarithmic scales. These are earthquakes, decibel scales, and pH scales. Basically, the way that the Richter scale works is that every factor is a factor of 10. So if I was comparing the San Francisco earthquake at 7.9 and the Turkey earthquake at 6.9, San Francisco was actually 10 times stronger. So the way it works is an earthquake that's magnitude 8 is 10 times more intense than earthquake 7. 7 and 3 is going to be 10 to the 4th times, or 10,000 times stronger, because there are 4 magnitude powers in there. 6 to 5, or 4 to 5 would be 1/10 as intense, and then 5 to 6 would be 1/10 as intense. So this is going to be 1 over 100. Or I could go 10 to the exponent of -2. This is also going to be 1 over 100, or 10 to the -2. So basically the way this works is that you take your two magnitudes, and then you go 10 to that power. So 1960 Chile, 9.5, as intense as 1976 Italy. 1976 Italy is 6.5. So if this is 6.5, this is going to be 10 to the 3, or 1,000 times as intense. So when we're comparing earthquake intensities, the scale is this, where I0 is sort of the standard earthquake we're comparing against. But all we really care about is this formula right there. So in general, there's actually 3 things we compare. There's our comparison, or our ratio, I'm going to call it. And then there's magnitude 1 and magnitude 2. So all we need is to do this. We just compare them. So 9.5, then 7.8. I'm just going to go my ratio, which is I over I, is just 10 to the 9.5 minus 7.8. 9.5 minus 7.8 is going to be 1.7. And I don't know that off the top of my head, but my handy-dandy calculator sure does. So 10 to the exponent of 1.7, 50.1. So it's 50 times more intense. This one here, 7.5 is 375 times more intense. So this is going to be, the 375 is my ratio. 10 to the 7.5 minus something. All I'm going to do is do the log of 375. Log base 10, and then the log base 10 of each side makes this just 7.5 minus m2. So if I go log of 375, that's 2.57. That means the difference in magnitudes is 2.57. If I go 7.5 minus my answer, that gives me that 4.93. So the second magnitude was 4.93. Loudness of sound works the exact same way, except that we usually would be doing it with bells. because that's too big, we use decibels. Decibels just means 3 bells. So power saw is 120 decibels, which really just means 12 bells. Phone dial tone is 80 decibels, which really just means 8 bells. Because 12 and 8, it's going to be 1,000 times, 10,000 times, 10 to the 4th, as big. Jet engine's 145 decibels, or 14.5 bells. 125 bells, or is 12.5 bells. I subtract them. 14.5 minus 12.5 is 2. So the difference is 2. 10 to the 2 equals 100. Whisper of 30 and conversation 60. You might be inclined to say, well, it's half as loud. In actuality, though, it's 3 minus 6 is negative 3, so it's 10 to the negative 3 times as loud, or 1 over 10 to the 3, which is 1 over 1,000. Comparing the loudness of sounds, so we just use bells, and it just works straight out. If we have decibels, first we have to find the difference, divide it by 10, and then work. It's easiest just to use bells. Instantaneously look at the question and be like, no, that's dumb. I'm going to use bells. So, this one, if I've given this equation, show the decibel level for the threshold of pain is this. What I would just do is 125 decibels equals 10 log I over I naught. And then that leaves me with, if I do to the 10th, this is 12.5 decibels equals log base 10 of I over I naught. And now if I undo my log, is 10 to the 12.5, and that gets me this thing, especially if I multiply my I naught over the other side. Again, the standard question is how many times more intense is it? So here I just go 6.7, that's it in bells, minus 2.2, which is 4.5, so it's going to be 10 to the 4.5. 10 to the 4.5. Ta-da! 31,000 times more intense. Two telephones at home ring at the same time with a loudness of 80 decibels each. Does that mean that the loudness is 160? No, the intensities add. So if I had I1 plus I2, those would add together, but the intensity is going to be I naught times 10 to the 8, because that would be decibels, plus I naught times 10 to the 8th, which is the same as what am I doing here? Log I over I naught. Well, anyway, if we assume this, if we assume that I naught is basically just like 1, goes away, or I can even factor it out, this becomes 10 to the 8th plus 10 to the 8th, which is 2 times 10 to the 8th. And then if I did the log of that, that's going to give me just 8.3 or 83 decibels. And again, remember, a single jump in decibel, or in bells, that's bells, or 83 decibels. A single jump in bells is a factor of 10, or a factor of 10 in decibels would be a factor of 10. And it's not going up by a factor of 10, it's going up by a factor of 2. All right, same thing is true of pH. So all I have to do is compare these two things, tomato juice and water. Tomato juice is here, pure water is here. It is a factor of 3, so it's going to be 10 to the 3rd, or 1,000 times as acidic. Eggs are, and the thing that we need to remember here is that you can talk about going up the scale of alkalinity or going up the scale of pH. So eggs are more alkaline by 1 pH degree, which means 10 times. Milk of magnesia is 10.5, and blood is 7.5. So this is 3. It's 10 to the 3 times as acidic, as basic or alkaline as blood, because it's further down the alkalinity scale. What is 100 times as acidic as normal rain? Normal rain is 5. 100 times acidic would be 10 to the 2, so I need to look 2 jumps away. There it is, it's vinegar. 2 units away. Vinegar is 100 times as acidic as normal rain. Eggs are, here they are, 8. Washing soda is 12, and eggs are less acidic. So it would be that times 10 to the 4, or a -4 change. Back in here, comparing acidity and alkalinity, again, we basically just do the same thing. Whatever it is, we look at our 2 scales, we subtract the 2 scales, look at the difference, and compare them. Now, for pH, they also give us this. This is the standard definition of pH, where H plus is the concentration when it's in this here funky square brackets. So pH of 5.7, negative log base 10 of H plus. Therefore, H plus is just 10 to the -5.7, which is that, or 0.000002, or 2 times 10 to the -6. Either way, this last one here, determine the pH of a solution to the nearest tenth if the hydrogen ion concentration is that. Well, again, pH equals negative log of the concentration. So all I have to do is go negative log of 3.4. Now, if I want to do this, I could go times 10 to the, or you can also use the E button. And this means -4. It's sort of scientific notation. So the pH would be 3.468 or 3.4. Also, if I put it like this, times 10 to the exponent of -4, that gives me the same number as you can see. So that's the way those ones go. Hopefully that makes sense. Should be relatively straightforward. If not, come and get help.